Bismillah ar-Rahman Rahim. Bismillah ar-Rahman Rahim. Assalamu alaikum. Good morning, everybody. I'm very pleased to announce today's speaker today, uh, Professor Heather A. Khwaja, who is actually adjunct faculty of ICCBS, and I have to read it actually before. He is working as a senior research scientist at Wordsworth Center and is associate professor at the Department of Environmental Health Sciences, University of Albany. Uh, he worked with Professor Sherwood Rowland, who is a Nobel laureate of 1995 at University of California. Uh, Dr. Khwaja is a director of Laboratory of Inorganic and Analytical Chemistry at Woodward Center for last 21 years. And he has huge experience, 31 years, more than age of most of you, for of solid research experience on environmental projects and have more than 75 publications in international journals. He is editor and editorial board member of many international journals. Today, he will talk about particulate matter and its health effects, what is known and what needs to be done. So, stage is yours, sir. Kindly. Yes.
Assalamu alaikum. So it is indeed a great honor for me to be a part of this great institution. And thank you for your kind introduction. I am thankful to Dr. Imran, Dr. Nadeem, and all faculty members. So today I'm going to talk about the particulate matter, health effects matters, what is known and what needs to be done. Basically, I'm going to share some preliminary data from Lahore study. I have initiated this study in 2022 on smog in Lahore. Initially, this was initiated at University College, the Government College, the University, GC University, then the FC, and then now University of Central Punjab. So what we are doing there is monitoring air pollutants during the smog episode and then after smog episode, and we would compare the results. And also, I am very much interested to get the hospital data so that we can see is there any association between the pollutants and cardiovascular and pulmonary diseases. Let me just briefly mention, I finished one project with Aga Khan University that was started in 2008, ended in 2012, somewhere there. So we monitored the air pollutants at different sites in Karachi. It was a 4-year project. The first year we collected samples from Tibet Center and Kurangi, the residential and industrial. The second year we changed the site. Then third year we changed the site. So in that way we just covered the whole Karachi. And simultaneously we were collecting the hospital data from NICVD, which is a major tertiary care hospital for cardiovascular, and JPMC, and also from Aga Khan. They were our collaborator. So far we have published about 10 papers. I have produced at least 3 PhDs on that project. Then later on, I got the funding from King Abdulaziz University in Saudi Arabia. Same project on the western part of Saudi Arabia. We chose four cities: Rabigh, Jeddah, Mecca, and Medina. Same thing, we collected PM 2.5, the particulate matter less than 2.5 micron. We did the chemical characterization, and we simultaneously collected hospital data from cardiovascular and pulmonary diseases. So far, we have published papers from Rabigh and Jeddah. Right now, I have a PhD student from Saudi Arabia who is working on Makkah and Medina data. And I was lucky that during this project, I performed Hajj. And during Hajj, I also monitored real-time particulate matter and black carbon, ozone, and also. Anyway, so that was my brief background, particulate matter and health effects matters. So the outline of today's talk would be just brief background, three major air pollution disasters of the 20th century, air quality and health, and then photochemical smog, what photochemical smog is, and the smog pollution problem in two Punjabs, our Western Punjab as well as Eastern Punjab. And we share the same problem. And it is a major problem in both Punjabs. It started in somewhere in 2006, and now I think it is means most of the cities in Punjab, our Punjab and Eastern Punjab, they are suffering because of smog. And not much work has been done. That is another problem. And then I would share with you some preliminary data, what we have done so far. So let me start with defining air pollutants, what air pollutant is. Any pollutant which exceeds the guideline is considered as pollutants. There are two types of pollutants, the CAPS and HAPS. CAPS are criteria air pollutants and HAPS are hazardous air pollutants. CAPS, 6 pollutants are there, and HAPS about 200 pollutants. Most of them are either carcinogenic or toxic. And generally, the regulatory agencies, they set the guidelines for CAPS, and we have WHO, the World Health Organization, and also we have in US, we have US EPA. In each country, we have some protection agency. In Pakistan, we have Pakistan EPA. So basically, they set the guidelines to protect the health of the general public and also the occupational people. The US EPA, for example, in US, what we do here is we go through the literature and we see whether this guideline is enough or we have to lower the guidelines. 20 years back, particulate matter, TSP, the total suspended particle, was very important. And then 20 years back, PM10, now PM 2.5, and down the road, PM 2.5 means fine particulate matter. Now we are going ultrafine particles and nanoparticles. So this is the timeline. So we started with total suspended particles, or SPM, suspended particulate matter, PM10, that is less than 10 micrometer, then PM 2.5. Right now, a lot of research is being done in developed countries on PM 2.5. Also, nanoparticles and ultrafine particles. As you know, there are two types of pollution. It's outdoor air pollution or indoor air pollution. The types of pollutants, inorganic pollutants, organic pollutants, biological pollutants. And then the primary pollutants are those which are directly emitted from the source. And secondary pollutants are those which are found in the atmosphere. Okay, so secondary pollutants, for example, sulfuric acid is one of the secondary pollutant. Sulfur dioxide is the main pollutant, and then sulfur dioxide react with the oxidants to give you sulfuric acid. Same with NOx coming from vehicular traffic, reacts with oxidants, give you nitric acid, and when it rains, it comes back as a hydrogen plus and nitrate or sulfate. Okay. So what type of sources? There are natural sources like volcanic activity or the wildfires. These are natural sources. We do not have any control on the transport of pollutants. They do not need any passport or visa to travel from one place to another. Then we have stationary sources. What those stationary sources are? These are large industries like power plants, coal-fired power plants, the steel industry or those. Then we have the mobile sources. So these are different types of sources, natural, stationary, and mobile sources. They all emit pollutants in the atmosphere. Our atmosphere is very oxidant. They convert into some other species, and then it comes back to Earth's surface. Here, I would just briefly go through the criteria air pollutants. And there are six criteria air pollutants, PM 2.5, PM 10, that is less than 2.5 micrometer and less than 10 micrometer. The second column is showing you the sources, where they are coming from, the vehicular traffic, industries, and then in the third and fourth column, these are the guidelines set by WHO. Okay, for PM 2.5, particulate matter less than 2.5 micrometer, the guideline for 24 hour is 15 microgram per cubic meter. For PM10, the guideline is 45 microgram per cubic meter. About 5 years back, the PM 2.5 guideline for 24 hours was 25 or 20 microgram per cubic meter. But now they are tightening these guidelines. So right now 15, probably down the road it could be 10. They are working on 10 and 5 microgram per cubic meter. Ozone coming from is a secondary pollutant. The 8-hour guideline is 60 microgram per cubic meter, carbon monoxide, sulfur dioxide, NOx, and lead. These are six criteria pollutant. Okay. The last column is the health impact. That is the most important one. Okay. EPI studies have been done in developed countries, and they have shown the linkage between particles, between particulate matter, and you name it, cardiovascular, pulmonary diseases, neurodegenerative diseases like Alzheimer, Parkinson's, dementia, obesity, pregnancy loss, loss of birth weight. So you name it, tuberculosis. So PM 2.5 has been associated with different health outcomes, cardiopulmonary and neurodegenerative, the diabetes, obesity, all those. Okay. So PM 2.5 is the notorious one. And a lot of research is being done in developed countries. Again, I think I have already gone through this. Where the pollutants are coming from, natural, large stationary sources, then the mobile sources. Now, in the developing countries, the major problem is the open burning of the garbage. This is the major issue in developing countries. We do not have incinerators, and wherever we find some empty land, we dump our municipal waste, we dump our hospital waste, we burn it, plastic and all those, the PCBs, the dioxins, the PHs, these carcinogens, and that's what we are inhaling. Okay, so it's really, really very pathetic condition in developing countries, including our Pakistan. You hear about air quality index. What air quality index is? Basically, it relates the concentration of criteria air pollutants to health outcomes. Okay. So EPA has given some formulas. You plug in the concentration of PM 2.5 or carbon monoxide or ozone, and that would give you some air quality index. So air quality index 0 to 50 is considered to be good, and 301 to 500 it is considered hazardous. WHO has said that if PM 2.5 concentration is 42 microgram per cubic meter, it would be considered a good air quality index. From time to time, on a daily basis, you see that air quality index is this. Okay, and the major problem in our major cities of Pakistan is PM 2.5. Okay, right now. Down the road could be ultrafine particles, or so probably I would not be in this world to go through the research on ultrafine particles, but you young people, I think, would be doing some research on ultrafine particles and the health outcomes. Let me go through some three major air pollution disasters of the 20th century. All these three air pollution disasters have common things. First thing, that they were in valleys, low wind speed, low temperature, and fog, and very high air pollution concentrations, the particulate matter and sulfur dioxide. So in this one, this episode occurred in eastern Belgium in 1930, Valley. It was a 6-day episode. It started December 1st. Low temperature, fog, low wind speeds, and also very high concentrations of particles and sulfur dioxide. In this episode, about 63 people died and 6,000 illnesses were observed, and the common symptoms were pulmonary symptoms, the cough, shortness of breath, and all those. The second air pollution disaster happened in Donora, Pennsylvania in 1948. Again, a valley, very high concentrations coming from the steel industry, particles, sulfur dioxide, and other. And in this case, about 18 to 20 people died due to this episode. The major air pollution disaster of the 20th century was in London, 1952. Again, very high sulfur particle concentrations, burning of coal, and about 4,000 people died during this episode uh, between December 5th through 8th. Okay, and 4,000 people died during this episode. Here I am showing you three plots. This bottom one is the particle concentration in milligram per cubic meter as a function of December 1st through 15th, and the episode occurred right here, 5th through 8th. This is sulfur dioxide concentration as a function of December dates. And third one, death per day as a function of December 1st through 15th. What do you see here? That before the episode, the particle concentration was around 0.5 milligram per cubic meter. As soon as the episode started, it jumped up to 1.6 milligram per cubic meter, and then it came down and came back to around zero point 0.5. Sulfur dioxide concentration before the episode, zero point 0.2 parts per million, increased up to 0.7 ppm, came down, and same. But look at the death. Before the episode, about 300 deaths per day. It jumped up to 900 deaths per day, but did not come back to the original 300. It's somewhere around 500 deaths per day. So this was the very severe smog episode of the 20th century. You see the WHO reports. It comes every year or every 2 years. You can also see some other reports, the Health Effects Institute reports. According to this report, more than 8 million people die globally on an annual basis. More than 8 million people die every year because of air pollution. Out of this 8 million, 4.8 million people die because of outdoor air pollution, and about 3.7, 3.8 because of indoor air pollution. Now, in addition to this, there is a loss of life years. Okay? I see different numbers about Pakistan. Sometime I see that we lose about 3 years on an average, and in Punjab we are losing about 7 years. So that's a big because of this smog and other problems. Now this distribution is not uniform. Two-thirds of the death and two-thirds of the lost life years occur in developing countries of Asia. And Pakistan, India, and China are there. We are in top 3 or top 4. Okay. So what are the consequences of these air pollution? Haze, smog, poor visibility, climate change, okay, impacts on our ecosystem, impact on buildings, and most importantly, our health. Okay, that is the major problem. And as I said earlier, particles, the PM, which is a major component of outdoor air pollution, it is considered carcinogenic by IARC, and it is considered as group 1. Now, why PM 2.5 is so critical? Okay, you see here, bacteria is about 1 micrometer size. PM10, that black, and our red blood cell is a 7 micrometer. Our hair, which we can see through the naked eye, is about 70 micrometer. So PM 2.5 is so tiny, is so small. Okay, we are sitting in this hall, lot of PM 2.5 embedded with pollutants coming from these walls, coming from the carpet and all that, and we are inhaling those fine particles. They go deep into the lungs, they go into the alveoli, and then from there they go into the bloodstream, and they impact on our health. So that's why PM 2.5 is really, really very major issue. And these fine particles are embedded with, you name it, carcinogens, toxic, inorganic, organic, and that's what we are inhaling. You go outside, the burning of the garbage, The PCBs, dioxins, all those, you are inhaling those. Okay. As I mentioned earlier, a number of studies have been carried out in developed countries mostly because of resources they have, and they have shown the linkage between PM 2.5 and other pollutants with cardiopulmonary, cancer, obesity, diabetes, TB, mental health. I think right now I have seen quite a few papers where they have shown that the air pollutants, PM 2.5 and some gaseous pollutants are linked with mental health. Okay. Neurodegenerative diseases, the Parkinson's, Alzheimer's, pregnancy losses, reduced birth weight, and our life expectancy. Okay. Now, in case of Pakistan, I think we are facing a very pathetic condition, and our policymakers and our scientific community, they are not paying any attention towards this. Why there is a big problem in Pakistan? We have a major problem of increase in population, increase in urbanization, and according to the UN report, by year 2030, 50% of people in Pakistan would be living in urban areas. So 50%. We have a very poor infrastructure. Okay? I have traveled Karachi and onward. We have very poor infrastructure. I think that is another problem. Vehicular traffic. Okay? The quality of fuel is very poor. They are not inspected. Okay? They are emitting a lot of this incomplete combustion. Industrial expansion without any check. And we have lax environmental legislation and its enforcement. On paper, you would see a beautiful laws and regulations. Implementation is not there. We have an inadequate transport infrastructure. Karachi is the only mega city in the world which does not have the mass transit system. Okay. This is the only mega city among 20 mega cities in the world. We do not have the mass transit system. That is a major problem. You go to Lahore, I went to Lahore, coming from Lahore and Islamabad, same problem. We have about 30 million people living here, and we have about 8, 9 million automobiles on the roads of Karachi. About 30% of Pakistan's automobiles are on the road of Karachi. Same problem in Lahore, same problem in Islamabad and in other major cities. What is lacking is poor infrastructure as far as the mass transit system. Okay. India had the same problem. 30 years back, because I'm involved in some international peer-reviewed journals, I see their papers. 30 years back, the quality of their paper was not as good. But slowly and gradually, they built the environmental departments. And now their publications are as good as in any developed countries. Delhi did not have the mass transit system. They have introduced the mass transit system in Delhi and Bombay, and they are doing some more things to control the air pollution. Pakistan, let me be very honest, is very pathetic condition. Okay. Politicians are not doing anything, and I always say that we are dependent on international lenders. Okay. IMF, World Bank, Asian Development Bank, they give money to us. I think it's their responsibility too to attach some tie that, okay, we are giving you $100 million, you have to take care of some environmental, this section or that section. Okay. I think that is the need of the hour. weak institutions. We really need students trained in this field. Not sometimes I feel that environmental is a fashion. Some people are in zoology department or in plant something, and because environment, so they are involved. Their training is not in that field. Okay. The need of the hour is we have to train undergraduate and graduate students in this field. We need skilled people in the field. Lack of skilled research and policy personnel. I think these two. And on top of all these, we really need a good, reliable data on a long-term basis. Last year, I was invited in one workshop. It was IC this is in Nepal, funded by US State Department. And I was invited during this workshop. Our DG EPA was also invited, and scientists from India, policymakers from India, Bhutan, and all those countries, we were all there. And everybody, we were just talking about this problem, smog problem in two Punjabs, what we can do. In Punjab, we needed 250 monitors. Okay. How many were there? Only 5 monitors were there. Only 5. Okay. And DGEPA, I think she mentioned that, okay, we do not have resources, we do not have the skilled people. So if you do not provide a good quality data, how policymakers can do something? Okay. So this is the need of the hour. We need to train our students in this field. We need good quality data for air pollution monitoring. What are the health impacts on a long-term basis? Not the patchy, unreliable data. We need good quality data on a long-term basis. Okay? And all these factors in Pakistan, because of these, we have a major environmental problem. It's impacting our health, and it is also impacting our ecosystems, water quality. The food we eat is not as good. The water we drink is not good. The air we breathe, not good. So all three things, I think, is the problem. Okay, so let me change my gear towards the smog. As you know, the VOCs coming from different sources and the NOx coming from vehicular traffic, and then it reacts among VOCs and NO2 in the presence of sunlight, and it gives you ozone. So currently in developed countries and also in developing countries, the PM, particulate matter, and ozone are the main culprit. These are the two notorious pollutants. And here is the picture of Lahore, the Bashai Mosque. Smog, I think, is a major issue. I'm giving you the picture of Los Angeles, 3 women walking on the sidewalk, and behind you see the city hall. Okay. I have lived in Los Angeles. The problem there is it is a valley, and the NOx, if your plane is coming, you would see a thick brown layer of NOx, thick brown layer, and they have a major smog and haze problem. China is facing the same, and the bottom two pictures of Delhi, India in 2019, and school children during the smog in Lahore in 2023 picture. The problem In our Punjab, the West Punjab and East Punjab, uh, I think we are really breathing very poor toxic air. As I said, the smog season starts somewhere in November, and the stubble burning starts in October. And in both, I think the East Punjab, they do stubble burning, and our Punjab, we do stubble burning. There is a blame game. We say that India is doing it, and India is saying we are doing it. And I think the problem is there. Okay. The smog season is a very routine affair, and it is spreading. Not only Lahore, Multan, and all is spreading. I think in towards Islamabad and in northwest frontier province. And this poor air quality is not only during the smog episode. I think throughout year, you would see the PM 2.5 concentration in major cities of Pakistan are extremely high, very high. Okay. So vehicular traffic, industries, plants, brick kilns. I think in Punjab, I think that is another issue. Most of these brick kilns are traditional. Okay, they did not adopt the zigzag technology so far. Stubble burning is also a problem. Indian Punjab, according to this, I have giving you references of Jain and Ghosh, 46 million ton of stubble burning in Indian Punjab. And then I'm giving you this Thumeti 2015. They use the satellite data, and they show 60% of the agricultural areas in Punjab and Haryana. And recent studies have also shown that the pollutants, the transboundary transport, they travel from Punjab, East Punjab to West and West Punjab to East. I think wherever I go, people just say, well, this is India. That's what India is doing it. I don't believe that. I think this is our problem. Let's solve our problem. Okay. And I always give one example. There in 1815, there was a volcanic activity in Indonesia. So if you click Professor Google, he would tell you that 1815 volcanic activity happened in Indonesia, and the pollutants, the particles, the gaseous pollutants, they travel to America, northeast of America. And there was no daytime, and guess how many people died? 93,000 people died in that episode, volcanic activity. It was natural, no control. It started from Indonesia, and we said little ice age, fog, and if you look at the paintings of that time, you would see a beautiful sunset because the painters, they depicted that whole area. So these pollutants do not need any passport or visa to travel. The transboundary would always be there. So we need to talk to the Indian authorities, the scientific community, and just see what we can do to control this transboundary transport of pollutants. This is a very important report. It's called R Smog Report by UN, and that is the answer that people say that India is doing or Pakistan is doing. The main point here is the 80% of the pollutants are coming from two sources. This is the source apportionment study. 43% coming from the vehicular traffic, 25% coming from the industries, and see how much coming from the agriculture. only 20% coming from the stubble burning. So this is the major report by UN that is showing that 80% of this coming from transport, industry, and power generation. Only 20% is coming from the agricultural burning. And this is really an important point here. So we need to address where they are coming from. The vehicular traffic, 43%. If we address that, we can cut down the smog problem. Or the industry, 25% coming from there. So these are the two sectors where we need to control the emission. What is the problem? I think both Punjabs, I think they face poor air quality, health impact, and the direct cost because of the health, and the indirect cost from different factors. Okay. What we need is we need to do the cost benefit. Okay. In US, uh, the EPA and the scientific community just discussed. Let's see the cost because of air pollution and what we can do to control the emission or pollution. So they started in 1980. They invested a lot of money to control the air pollution. From 1980, we are saving $200 billion on an annual basis. So far, we have saved $6 trillion. So what we need, I think we need some economists, or we need to do the cost benefit. Because of this smog episode, for 2-3 months in Punjab, how much because of health cost, because of kids are not going to school, the workers are not going to work, airline is not functioning, all that. It's a very simple task. We need to do a cost and then benefit. Pour some money to control the air pollution. What are the challenges in two Punjabs? We need reliable, good quality data on air pollutants and also the population exposure. We need where they are coming from, the source apportionment. We need epi and toxicological studies. We need some biological markers. We need modeling studies. Insufficiency of institutions, legislations, and enforcement. That's a big issue. We can control the transboundary transport of pollutants by talking to the government on a government of India and government of Pakistan. They should come on one platform and see what we can do. Education of students. I would say that I think we need to have a syllabus starting from grade 5th. Bring awareness about environment and impact of environmental pollution. Okay. We need health professionals and the awareness among the public. Electronic media and the print media is very powerful tool. Okay. From time to time, I think we should engage the print media and the electronic media. See, we are being affected by these air pollution. Okay. Lahore, a city under strain, getting reliable data even for the population and the vehicular traffic is a big task. Whenever I want to see what is the population of Karachi or Lahore or any other city, I get different numbers. How can I rely which one is a Karachi is starting from 16 million to 30 million. So which one is the correct one? Total number of automobiles, if you see the statistics from the government, is giving you different from private, all that. So getting the reliable data is another problem. Anyway, Lahore, about 15 million people living in that city, beautiful city. We have a large industrial base. Brick kilns is a problem. Vehicular traffic, 7 million people living, 7 million automobiles registered. No mass transit system. Brick kilns, open burning of waste is another issue. I started this project in 2022. I'm going to share some preliminary data. This time, what I did is my PhD student from here, I asked him to come. So he came to Lahore, and what we did is we saw what are the major roads, and we did the commuters exposure study uh, on different routes for whole 10 days. We had real-time monitors for particles, size segregated particles, PM1, PM2.5, 7, 10, and TSP. We also monitored the black carbon. We also monitored ozone. So these three monitors, gadgets, started from bike. So two people on the bike, and we went through all those roads. So we would see what are the hot spots, what are the concentrations of each pollutants, how the commuters are being exposed. We would do some inhalation dose, all that. Okay. So this was really, I'm very pleased to see that it was all done in 10 days time, and we would publish that work. If you want to reduce the ambient particle concentrations, we really need the nature of pollutants in ambient air, what are the concentration levels, where they are coming from, how they are impacting our health, how they are impacting our ecosystem. Okay. So this study was in Lahore. What we did is we have this PM2.5 monitoring for 24-hour samples, and we did about 2 months sampling during the smog episode and about 2 months after the smog episode. After collecting these samples, we have done it, the non-destructive analysis of these filters. We did the black carbon. Black carbon is a major component of climate change. Not much data are available on black carbon. Then we have done some trace metals analysis, about 30 to 40 trace metals. And then also we would do some anions and cations using ion chromatography, and we would do some organics. This time we are going to do some toxicological and biological studies using these filters. So PM2.5 samples, I think I'm collaborating with Dr. Akhyar. He is the dean now. He started his journey. He has a PhD from chemistry department, University of Karachi. Then he joined FC University. After that, I think he started with the GC University, then FC, and now he is a dean at University of Central Punjab. And so basically, I think there is a big road, very heavy vehicular traffic, and we set our the sampler right here, and this is the window, and the main road is right here. Very simple setup. We have a cyclone separator for PM2.5, the filter holder. We have the PTFE filters connected with the Tygon tubing to the pump. Okay, and the rotometer is used to check the flow rate. For PM2.5, you have to have 16.7 liters per minute flow rate. Okay. So samples were collected on PTFE filter, 47 millimeter for 24 hours. And how we do this sampling? Before the sampling, we take these filters pre-conditioned in a controlled temperature and humidity room. Uh, we weigh the filter, put them in petri dishes. Then I sent these filters to Dr. Akhyar, and then they collected the sample, put them in petri dishes, then put them in the refrigerator, and then they sent back the samples to me. And then using the microanalytical balance, we weigh them again. So PM2.5, now the trend is using the sensors. I'm not much into sensors. It's a very cheap, $10 to $100 sensors. It can provide you some data. How reliable the data is question mark. Because the sensors are very sensitive to humidity. Okay. The US Embassy, they have started monitoring PM 2.5. They have put these sensors, monitors in Karachi consulate, US consulate in Karachi, Lahore, and Peshawar. They started this in 2022. Okay. So, okay. So here is the blank filter right here. And this is the 47 millimeter collected sample. This is the controlled temperature and humidity room. One of my students, he is weighing. This is the microanalytical balance. Weigh them very correctly. What we do is the difference of weight after sampling and before sampling, and then divided by the air volume. The sample was collected for 24 hours, converted into minutes, 24 times 60, 1440 minutes. 1440 minutes divided by 16.7 liters per minute, the flow rate, minute would cancel out. It would give you 24,000 liters. Divide by 1,000, it would give you in cubic meter. So you express the concentrations of PM 2.5 as microgram per cubic meter. Okay. WHO guideline and US EPA guideline is 15 microgram per cubic meter. So what we are going to do is after this PM 2.5 mass, we have done it black carbon analysis, we have done trace metals analysis, and we are going, and the anions and cations, and then we are going to do some organics on these filters. We are going to do the concentration, comparing it with WHO guidelines, the temporal variation, seasonal variation, okay? And then we would do, if I get the hospital data, then we would do some epi studies to see the linkage between air pollutants and cardiopulmonary diseases. So that is the goal of the whole project. Okay. So let me share with you Let me share with you the 2022 PM 2.5 concentration during the smog episode. This was started in 14th of November, and we ended on 1st of February. Okay. These are 24-hour samples. This is the WHO guideline, 15 microgram per cubic meter. What do you see here? Not on a single day, the PM 2.5 concentration was close to WHO guideline. Extremely elevated PM 2.5 concentration was observed, extremely elevated. Okay. And 200 microgram was very common. The lowest concentration we have observed 110 microgram per cubic meter, the highest 420 microgram per cubic meter. So you divide by 15, you see the exceedance factor. Not on a single day, the concentration is close to WHO guideline. So this is the 2022 data. Air quality index based on PM 2.5. What you see here is 60% of the days the air quality was unhealthy, 35% days very unhealthy, and 5% hazardous. Okay, not on a single day the air quality was good. So then I asked my student to do some windrows plots or backward in time trajectories. This is the windrows plots to see where the air was coming from. Okay. So when the concentration was low, then the air mass direction was from west and west northwest. And when the concentration was 420, it was all over east, northeast, coming from south and south, southwest. So what are the lessons and recommendations? PM 2.5 concentration extremely high. Data showed levels of PM 2.5 exceeding the WHO guidelines. And we are going to provide more data for policymakers. What are the solutions? A way forward. We need political will. Okay. We need capacity building. We need to train our young scientists, the undergraduate and graduate students who would take up the good positions down the road. Okay. We need good quality data, the accountability and all that. So research is needed for the source apportionment, where they are coming, epi studies, some toxicological studies. We need collaboration. We really need collaboration. Here, our culture is little different. We shy away from collaborations. Okay, we do on an individual basis. So take out all those cultural taboos. Let's bring the resources together, do some good collaboration. One person cannot do everything. Involve good air pollution monitoring people, good meteorology specials, epi people, physicists. So make a team. Make a team. I think, let me be honest, I think in our culture, the problem is insecurity among ourselves. Take out all those jealousy factors and all other factors. Okay, these are taboos. Bring scientific community together. Okay, that's what I have been doing since 98, 99. I started a project through UN, Karachi and Islamabad. Okay. Now I have done in Lahore. Yesterday I gave a talk in Pakistan Atomic Energy. They want to collaborate. I'm going back to Lahore. LUMS people, they want to collaborate. So make a team. Okay, make a good team and provide good quality data. Train people. I think that is the need of the hour. So here are some acknowledgements. My university, University of Central Punjab, and Dr. Kamran Khan, he is my PhD student and he is really very sound. I have taken him to Aga Khan project. I have taken him to Saudi Arabia project, and in Lahore, he is very much involved. Very good person. Thank you so much for your attention, for your patience. Okay, thank you so much.
Thank you very much, sir. Thank you very much for exciting lecture. The most important aspect, which I like the most, is the relevance of your research to the current day problems. That is something we need to learn. Everybody, we should learn. We should do the research to help the society. The current day questions? Anything?
Questions?
With regard to I retired from PCSIR. I should say back with you. When Karachi University started program in environmental sciences, I came here. The professor sitting over there, it will give admission. Similar case happened in NDU. They say, oh, you are from chemical engineering, structural engineering. So, anyway, environment multidisciplinary. Okay, anyway, PCSIR did the project on a hospital-based management. We developed an intelligence incinerator, for one cost very high, and we gave it to the JPMC. Over there, went the assistant director. He said, "What is you giving now? हम तो कचरा बेचते हैं, आप हमारे लिए मुसीबत लेके आ गए." This was the comment. So the problem is for all the sides, as you mentioned. Sorry to you over here. I am also visiting faculty over here, Karachi University, Zaria University, Banana University. Problem lies with our academic people. They are very young. I'm sorry to say that. They are very sorry to say that. Because I have been all the universities, they do not allow you to do anything. In Karachi University, I went 40 years back in environmental department. Did you? He was at that time. I gave her proposal about the Particulate emission project. And the very next day, he went to the expert meeting. Actually, we have a problem of Particulate. So one of them, expert, he knows me. He said, one person came to you about this bag, and you refused him. Why? Now you are taking the same problem. We have to do it. Take care of it. So this is the problem over here.
I think cultural taboos are here, and I am very frank. And I think yesterday I spent the whole day with atomic energy people, and I said very bluntly, this is our problem. I think atomic energy, there are two, Pinstack and Yas, both have set up. It's a duplicate, it's a wastage of money. Under one umbrella, atomic energy, two, Pias and Pinstack, same setup, same. Why? Why don't you talk to each other? I am a product of this society. Over there, when there is a problem, we bring it on the table. We discuss, and whatever is the solution, we just go ahead with that. As I said, I think jealousy factor, high ego, and insecurity, sharing all these things is a major problem. Let's try to overcome these issues. I'm very blunt. People don't say these things. Let me tell you one. Last year I came here, and I think what was his name?
Ahmed, Dr. Ahmed.
Dr. Amir was there in that workshop. That was at Dow Sindh or Dow Medical College, SMC. That was at SMC. So he gave the talk. Dr. Fatmi was there, and then I gave a small talk. Then there was a panel discussion. After panel discussion, some student, medical student, they asked some question, and I mentioned this thing that okay, here is our cultural problem. And I saw the moderator was there, and he was shaking his head because the third person, was there, full professor, and she did not like my comment. And she said, first of all, she started that I am a graduate of Columbia University. Fine. This is my observation, my experience, and I have expressed. I respect others' opinion too. She started again this blame game. Look, how far can you blame these incinerators? Not having incinerators is US or other countries are not saying not to have this. Putting all these garbage, mass transit system. Okay. Individually, whatever we can do, we should do it. So blame game, I think let's. Yesterday, same thing. One big scientist he asked this question. India is doing it. And that's why I bring that UN report. 43% is coming from the vehicular traffic. These are the issues. So, but blame game India is doing it. Well, transboundary, fine. It is a problem. Back in US, we used to have a acid rain problem in 70s and 80s. The problem was that in Midwest, there are a lot of coal-fired power plants. And the air mass direction was from west to east. And northeast of US, a lot of lakes and all that, they were affected by sulfur dioxide, sulfuric acid, and the lakes had a pH of about 2, 3 pH, very acidic. Yes, you can blame, hey, you are doing it, but the government level is set down. Here is your problem, here is our problem, what can we do together? Same thing here. I think we share the same problem. Two Punjab, one atmosphere. That's why I'm saying two Punjab, one atmosphere. They have problem, we have problem. Let's generate some data, good quality data, show this data to government level, and they should do the same. There are very sensible people there too. During that workshop, I encountered good visionary people. Sit with them, find out the solution. Let's fix our problem first.
I think we have to develop a core of technicians who can do the paid work. We do not have qualified technicians.
I think that's what I'm saying.
So this is more about policy making here on this,
Yeah.
but we can do at our level, as the Professor Faja, he has kindly agreed to co-supervise our students here. So we will have, tomorrow we'll have a, non-informal session with him for the students. So HCO will announce that, whenever it is. So we'll discuss with him and then at this time and then it will know. So we can discuss for, different projects with him and it is, as we kindly agreed to post to them. This was just a comment in between. Any other comments, any other questions, please?
Circular, Associate Professor and Ex-Chairman Department of Particulate. You talk about Lahore. I want to ask about the Karachi. Air quality index of Karachi is also very bad, as far as my little knowledge is concerned. So what do you think the smoke, how smoke is important because we don't have normally smoke in the Karachi as compared to the Lahore. So what do you think Karachi and Lahore, if we compare both with respect to the air quality index, so where we stand?
If you look at the WHO with these IAQ air, those reports, and the data from the US consulate, Karachi, Lahore, and okay, by the way, what I did is on this project, I took the US consulate data, and our data was PM 2.5. And then we plotted both the data, wanted to see if the sensor is providing some data and what our data. Big problem here. The correction factor is needed. Okay. So that's why I don't rely much on sensors. Start very basic research and provide good quality data. And here Dr. Kamran is here, I was talking about, and he has done a very good job. I think the commute exposure project in Lahore, bike, rickshaw, taxi, and all those and he has done a wonderful job. Anyway, so yeah, the air quality. The problem in Punjab and upper is the temperature. So because they have low temperature as compared to Karachi, and the boundary layer, the height is also an issue. Here in Karachi is little higher. That's why the pollutant concentrations are not as high. They are close. Sometimes Lahore is number 2, Karachi is number 4. And
Yeah, but it's not, maybe it's not more visible in the sense of smog. Because there we see smog, here we don't see. The only reason may be the temperature. Because of temperature that just stay here, condense here, but because the temperature is a little bit higher, it just goes up.
There's also
Otherwise, I think
Other
it's
also
AQI is
similar.
similar almost.
Similar.
I think the temperature inversion is taking part, the boundary height, low temperature is there. The type of pollutants are little different. Here we have lot of dust and lot of burning. Lahore is very clean. I was very impressed.
Yeah.
And they don't have as much garbage burning as we have. They have a problem of brick kilns, bhattiyan. That is the issue. Here, PM 2.5, we have done many studies here, somewhere between 100 to 300 microgram per cubic meter. Over there, because of the smog, during smog season, it went up to 400, 500 microgram per cubic meter. And AQI is very high. Our cities are very dirty. Go to Gujarat. I took a bus I wanted to see on GT Road, and very pathetic condition there too. So our major cities and also rural areas are being affected. So we need really good scientific process.
Thank you so much. Let me to say something. أنا عربي. أنا بس from Yemen. You are right. When Pakistan living in so big as Sweden. This what I see here. I am from Yemen. We didn't see it like this weather here, and now in my country, we didn't see it like this. What I am seeing here. When we come from Yemen to here, all my friends through the first week we will go to the hospital for this. All of us. We didn't say what happened here. How these people can live in this country. I visit Egypt and Saudi Arabia, Oman, Jordan. No like this. We didn't see like this. You can see the like this home in this weather, especially in the morning. So it's so serious issue here in
Very
Pakistan.
serious.
Or to solve by this issue. But is this any report about Pakistani people or why they are still Pakistan trying to solve like this issue about like agreements, Paris agreement, and the climate change? Pakistan is one of them kind of.
Yeah, it's a signatory. Yeah, they are there. I think those things I don't. We have to start some basic things, provide some good quality data, enforce our legislators, and Ministry of Environment. Let me give you one more example. I think there was a Minister of Environment, I'm not going to name, and he came to US, and we told him that we need incinerators. So he was very excited, and then we took him to different places and targeted really good incinerators. They were, I think those incinerators were collecting the garbage, municipal hospital, sorting them out, providing electricity. That kind of incinerator was there. 3 or 4 meetings with us. We took him to different places. In the end, what he said is, where will we get the funding from? I said, you are the Minister of Environment. So, and then he was thinking, I can see, he was thinking about his cut and or that kind of thing. Okay. So these kind of things, I asked him, what are the resources that he said, the money we get from the government is just to pay the salary of the employees, pay the telephone bills, and pay the electricity bill. So this is the pathetic condition here. I think we need to give money towards education and environment. At least 0.1%. At least some money is needed. We are losing a big chunk of money because of air pollution. And I said, $200 billion we are saving in US every year because the investment was there. People say that we don't have resources. I don't buy that. IMF, Asian Development Bank, and all that, they are coming and they are pouring a lot of money. You can have some small chunk from here.
I am Dr. Muhammad Farshawat. I'm currently I'm working as Director of the Institute of Environmental Studies. I was also mentioning that, but I have joined recently this institute. Thank you very much for pointing out this very important problem of air pollution. First of all, I will mention also a point that we eat food, we drink water, but what we are breathing that is more in quantity than we uh, uh, than our food and water. So here we have mentioned many things, and they are all correct. We should implement environmental emergency in our country, what the condition we are facing these days. Only one, you can supplement a question I have. On the base of PM 2.5, there are no sensor, particularly remote sensing data, and we are classifying the cities on the base of this data. And I agree with you, when you measure this data with different meter, you will have different reading. And when you collect the data manually, you will have different reading. So are these sensor-based classification are correct and justified? Because when we see Lahore is the worst polluted city in the world, Karachi number 2, number 3, and sometimes Faisalabad is number 1. Is this classification is justified, and is this ranking to show the world that we are the worst in this world?
I think as far as because they have collected the data. Sensors, if they validate their data with good monitors. For example, I checked their data against our. This is the best possible data one can produce. Okay, so whatever error is in the way, that's about it. And we are using micro-analytical balance. Okay. So this data is probably 4-5% uncertainty. I checked their data, and as I said, these sensors are very sensitive to the humidity. And humidity, winter time and summer time is all different. And that's playing a role. And I see a big correction factor is needed. Who is going to do it? When I would publish this, I would put that plot here.
It needs to be mentioned.
It needs to be mentioned. So probably they can use this correction factor for their own data.
And there are always we have complementary techniques to verify the results. So
I'd like to add one point. On the incinerator, in 2009, 48 incinerator was provided to the state hospital. And they have paid.
after 2 years,
Out of 48, 40 was not operating. Wouldn't operate. When 2010 I went for inspection, I was among the teams. Solid state. Only I found few of them in operation.
I think problems are there. Let's see what we can do to solve this. The problems are there. We can name so many. Let's see what we can do right on my issue. The problem is there. Yeah. Okay.
Thank
So,
you.
any other question? So,
You already mentioned that this is a transboundary problem, not a national problem. And we have also seen from different reports of you, COP 24 to 27 latest COP conference. The global north is the sole responsible of this problem, either in the form of air pollution or climate change. The global contribution of Pakistan is very little in this regard. And these reports also suggested that global north will fund to global south countries like we, Pakistan and India. So, as we have also seen that previously, Republicans like Donald Trump, who is totally against of these United Nations Framework Convention on Climate Change, and according to him, that climate change is not a real problem; it's a fake problem. And how you make analysis over this that right now global north will contribute to solve this problem here in global south.
these political things, blame game, let's keep this aside. This is our problem. Global North, Global South and all that. Air pollution is our problem. Our people are suffering. We are suffering because of air pollution. What can we do to mitigate this? That is the need of the hour. Forget about Donald Trump. I know what his policy is. He's against climate change.
Yeah, please.
Yeah, go ahead.
So actually, we need to finish now. It's running out of time. So my last comment is, it's not like if you invest on one thing and it's only on that. Everything is interconnected. If we invest on better atmosphere, it will obviously we can take some share from the healthcare system, because it will have the less burden of the healthcare system if we have better atmosphere. And on a lighter note, on Anil's point, I think after 1 year of stay, you're not going as much to hospitals now. So you have to
take him to the hospital 4 times.
but its frequency is getting less. So it means you have to develop immunity like us, like.
You are also getting
So,
immune.
thank you very much. Thank you very much for.
So in COVID season, we were.
आप किसी को नहीं मिले आए मैं आपके तरफ आता हूँ आपको कार्ड मिल गया ना इंशाल्लाह आप कल कल आप आइएगा टाइम देंगे होगा कल आप आइएगा
Dr. Sir. Yes, from biotechnology.
Thank you. Thank you
PhD मेरा ICCBS से पोस्ट मेरा Netherlands I have served HG as well as faculty member. अच्छा जी AP तो मैं यहाँ फिर 2013 में मैं पार्टिकल अब जो है अभी मेरा टेन्योर खत्म हुआ है चेयरमैन अच्छा 3 महीने का जी
Step on the agenda. Up I know.